Geeks for Geeks has a challenge for you, the 390 challenge. Choose what you want to learn in 2024 and aim to complete at least 90% of the course in the next 90 days. And if you do that, you get back 90% of what you paid for the course. We believe you can do that. Now all you got to do is commit to your success, commit with Geeks for Geeks.
Okay. So, hello everyone. I believe my voice is audible to you. Just let me know in the chat section whether my voice are audible or not. Is my voice is audible? Just let me know in the chat section whether my voice are audible or not. Is it audible? Anyone from the chat section? Yes, is it audible? I believe. Great. Okay. So in the today's session, we are going to start with the matrix as well as the determinant. We are going to cover the maximum part, but here we are not discussing the basic theories. Okay. Our main aim is over here because examination is very near. What I'm trying to do is from 2010 to 2023, the maximum question that has asked in the GATE examination for the previous year. Okay. We are going to discuss that part, right? So maximum questions, I will not I will try to give you 1 minute. Okay, that's it. Okay, because I need to cover the maximum question, so that suppose what my motive is, see, in from 2023, if I'm talking about 2023 to what my aim is from 2009 to 2023, this question this year of the questions that you need to understand, you need to practice before going in the examination to attempt the GATE DA examination. Okay, my focus of the branches are computer science, okay, then electrical, then mechanical, then civil, okay, then aerospace engineering, then chemical. These basically 6 branches, okay, or the electrical, mechanical, civil, chemical, okay, then computer science and aerospace engineering. These are the core branches on which the examination will ask the question. EC is also important, but the question that has asked in the mechanical or electrical, that is covered by the EC examination. So these 6 papers, okay, and this total years, okay, 14 years question paper, I'm about to discuss for today. Now my in this session we will discuss about from 2010 to 2022, okay. Remaining last 3-year question paper and one 2009 question paper you need to discuss on your own. Okay, you need to solve on your own because this much amount we cannot solve on here. Okay, so we will try to cover the maximum part. If it is covered, that's fine. If it is not covered, please try on yourself too. Okay, maximum PYQs we will cover. Okay, now let's start our session with the first question. If you have any doubt, you can ask me. Okay, then remaining we will go like this only. Just give me a minute. Okay. See, the first question is like this. We have a system of equation. Okay, I'm trying to solve the maximum question. Okay, I'm going to make you understand how these questions are need to be solved. There is a system of equation x plus y plus z is equal to 6, x plus 4y plus 6z is equal to 20, x plus 4y plus lambda z is equal to mu, has no solution for the values of a lambda and mu for the given value. Okay, so these are the options through which we have to find out which option is correct. As per this is as per the question, it can be seen that we have a system of a linear equation where the number of unknown are 3, that is the x, y and z, right? Here we have a 2 constant given. The first one is lambda and the next one is mu. On the basis of that, we need to find out which option is correct. Now, how many of you have remembered that if the system of a linear equation is given, then how we can find out whether this equation has a solution or not? Okay, Suppose there are three cases possible, okay? Either is a unique solution, okay, or there is a zero solution, or there will be the infinite solution. Any system of a linear equation, whenever we have solved, we only use these three techniques to find out whether the equation will be solvable or not. If it is solvable, then whether it's have a zero solution or infinite many solution, or it has a no solution. Same case that as we have covered in the system of a linear equation, we are going to cover in the matrix too. Now in the matrix form, how we can find out? We have to find out two things. The rank of the matrix first we need to understand. Okay, if you understand the rank of the matrix, then rank of the augmented matrix, rank of the coefficient matrix. Okay, if these two things you can make if these two things that you can find out in the examination, then now the question part is easy. Okay, you just find out the rank of the coefficient matrix, the rank of the augmented matrix. If both are equal, okay, if both are not equal, if the both are equal but the value is less than the number of a variable, this is the proper case. Okay, I have written the case over here, and trust me, this question, okay, this theory, please understand this theory, because in the examination, why I have leave that 2021, 22 and 23 question paper, because all question are repeated. Okay, that's why I leave that part, because if you have understood this part, you will get to know about that part too, right? See, if the rank of the augmented matrix is equal to rank of the coefficient matrix, and this is equal to the number of a variable, for the previous question that we are about to do, right, that we are doing right now, the number of a variable is x, y and z. Okay, so the number of a variable is equal to what? 3. In that case, the number of a solution is equal to 1. Case number 1. Case number 2, if the augmented matrix rank is not equal to the coefficient matrix rank, okay, and the number of a solution in that case will be 0. And if the augmented matrix rank is equal to coefficient matrix rank, and this is less than the number of a variable, in that case the number of a solution will be infinite. Just remember these three theories. I can give you the at least 10 questions of the GATE examination which directly come on this theory. Okay, even today also we are going to see at least 4 to 5 type of question on the same theory. See this, since the matrix has given, okay, as you know, this matrix is given as something like this: 1 1 1 1 4 6 1 4 lambda. Okay, this will be x, y, z is equal to 620 mu. Okay, so from here we can find out the augmented matrix. Once we are creating the augmented matrix, then finding the rank is only theory that you have to do. Okay, now I'm doing the operation for this row. This is row 1, this is row 2, and this is row 3. Okay, so on the row 3, see, I am just using my method to find out the rank. You can use any of the method. There are number of a method to find out the rank of the matrix by using any kind of operation. So you can perform any kind of operation to find out. Okay, so in the augmented matrix, that 1 1 1, if I'm doing that, R3 is equal to R3 minus R2. Okay, so it means that the first column, the first row, second row is as it is, R3 minus R2. Okay, so R3, that 1 and 0, and then lambda minus 6 and mu minus 20. These two things are equal. Okay, these two things will become lambda minus 6 and mu minus 20. R3 is performing as a R3 minus R2. That's it. Okay, so R3 minus R2, 0, 4 minus 4, 0, lambda minus 6, mu minus 20. This as we have got. Now again, once you have found out, then again what you exactly want to know, that if the rank of the augmented matrix is equal to rank of the coefficient, it is equal or not, or the number of a relation that can be founded with the number of a variable. See, if the lambda is equal to 6 and mu is not equal to 20, in that case the augmented matrix rank will be 3 and the rank of the matrix A is equal to what? 2. In that case, both the matrix has a not equal rank. Okay, so rank of the augmented matrix is not equal to rank of the coefficient matrix. In that case, it has a no solution case. Simple. Okay, simply we have to just learn this thing, just follow these things, and that's it. Okay, you don't have to worry about the other theories. Rank, augmented, coefficient, okay, and that's it. The question has solved. Maximum to solve this question, maximum 2 to 3 minutes max. Next. Now, if you're solving this question, see this question, Which of the following statement is true for the all real symmetric matrix? All the eigenvalues are real, all the eigenvalues are positive, all the eigenvalues are distinct, some of the eigenvalues are 0. Anyone give me any clue? Anyone can give me any clue? Okay. I believe you understand the symmetric matrix. Okay. Symmetricity is when A transpose is equal to A. Okay. Skew symmetry, A transpose is equal to minus A. Right. Then orthogonality and then Hermitian matrix. These all methods. Okay. These all things. The first thing is I have written the basic theory so that if anyone has no idea what we are exactly talking about, they can see the theories and they can understand what exactly we are learning. Okay. Those people who have already idea, they can make as a revision. A is equal to A transpose. Okay, this is the symmetric matrix. In that case, the eigenvalues are real and symmetric matrix are real. Okay, it means that here eigenvalues are real. For the skew symmetry, if A is equal to minus of A transpose, in that case, the eigenvalues are 0 or purely imaginary. Remember the theories. That's it. Okay. Next. Hermitian matrix, in that case, A is equal to A of A Hermitian. In that case, the eigenvalues are real and the skew Hermitian matrix same as the symmetry and skew symmetry. Okay, that minus will come here. In that case, that it will be 0 and pure imaginary. Okay, so if we have 4 cases possible now, our question has asked which of the following statement is true for the all real symmetric matrix. All real symmetric matrix, it means that the all eigenvalue will be what? Real. Okay, positive, distinct and 0. This is not a accurate idea because positive or negative, okay, that real number can be positive or negative, so we cannot say it's only a positive or 0 or distinct. Okay, but the eigenvalues all are real. That is the final answer for this question. Okay, in the question number 1, we have did we check the options after applying elementary operation? Wait a minute. There is a in this question. You are asking about this question, right? Saurav is asking, sir, in question number 1, did we check for the option after applying elementary operation? Actually, see, there is no need to check the options actually, to be very precise, because once you have found out now, after this you don't have to check, because see, if the all will be 0, okay, then the rank has an issue. It means that if the lambda is equal to 6 and mu is not equal to minus 20, in that case the value will be corporate. After that, we know that how to find out the rank of the matrix. If we are going to disturb that part, the rank will be also disturbed. In that case, the whole solution will get disturbed. Now, as per the solution is saying, as per the solution, since the solution is rotating about the mu, lambda and mu, and it also rotating about the 6 and 20, it means that the third row and the last 2 elements is the deciding factor. In that case, we have to see the options, but we have to also see the ranks too. Okay, Saurav, is it fine? Is it clear now? Is it fine, Saurav? Is it clear? Shall we move forward? Okay, if you have any issue, you can tell me. Okay, because now next, which of the following is not equal to 1 plus x plus 1 x is x square, 1 y square, 1 z square? Okay, these are the option. Just tell me in the chat section how to solve this. Okay, just give me the method of approach. Okay, that's it. I just need to know about from you, your guys, that how to solve this, how you will approach this question. The people who are in the chat box, just let me know how to approach this question. Okay, let me see. See, the question part is less, but the expansion is given as in the option. Okay, so the expand part is given as an option, but the concise part is given in the question. In that case, what you have to do, you shall start with the option. Okay, if you are evaluating the option, if this value is coming like this value, okay, then that's fine. but we have to find out what does not equal to. If this is not equal to this, then we got your answer. Okay, in that case you have to go one by one to 1 2 3 4. You have to solve that part and make then understand then is it that value and that value has equal value or not. For that you can use the multiple row operation or column operations too. If anything is visible, you can use that part, right? Now if I'm using that question number 1, okay, sure, no issue. Actually I'm writing now, that's why I'm standing in the middle of the board. Okay, I will be just aside from the board. Now what I am trying to do over here is the value is given as a 1x square, 1y square, 1z square. The next value is given as a 1 So I'm going to expand that part. Okay, suppose if I'm expanding that part, that will be 1, that will be x square plus x, that will be x plus 1, that will be 1, that will be y square plus y, y plus 1, that will be z square plus z, z plus 1. Okay, after doing the expansion, can we do one thing? Okay, that if I'm doing the further operation, C3 is C3 minus C1 and C2 is x. Okay, first let me do the C3 part. What will happen if C3 is C3 minus C1? Okay, in that case the x plus 1 minus 1, y plus 1 minus 1, z plus 1 minus 1. So in that case the value will become as a the value will become as a 1 x square plus x, y square plus y, z square plus z, that will be x, y, z. I hope you are agreed till now. Okay, now what you do for C2, now apply for this, for here C2 minus C3. Okay, if you apply C2 minus C3 now, then the value will be see x square plus x minus x. Okay, it means that this value will be discarded, y square plus y minus y, this value will be discarded, z square plus z minus z, this value will be discarded. Now this and this determinant, can you see that is this both part are equal or not? Okay, 1 x square x, 1 x square x, 1 y square y, 1 z square z, the following value is given like this. Actually these both are not equal. Okay, these both are have a negative value with each other, because if you rearrange the rows, okay, or if you rearrange the column, then you will get the original value. Suppose if I'm rearranging, if I'm just C2 is changing to C3, C3 is changing to C2, then that determinant will appear. But in that case there is a negative value that we have to apply before that determinant. Okay, so this is the only determinant whose value is not equal, and apart from that we are not even trying. Okay, because in the examination it directly given like this. So only the option number 1 is true, and after that there will be nothing. There will be nothing that we are going to try over here. Okay, is it fine? For that I have given you the detailed solution. You can go over here, you can check this. Switching two row and column causes the switching of the sign. Okay, adding the multiple of the row and column to the another row and column determine is the remaining same. It means that addition or subtraction will not hamper the value, but switching the row and column can hindrance the net value. Okay, now same operation I have done. As you can see, the same operation is done. In that case you can see that the value are not getting equal, it is getting negative after the determinant. Is it fine? These are all GATE questions, all previous year GATE examination question. Now by looking at these questions, I hope you understand what are the intensity of the examiner that they are about to ask, and what kind of a question they are only focusing on that. These questions are not difficult, just you have to understand the basic theory. Okay, so this is the basically This is the only reason why we are not making these things equal. Okay, I hope you understood this, guys. Anywhere, if you are feeling any issue, just let me know. Otherwise, I'm moving forward. Okay. Give me this question. Again, this question is same like the question number 1 that we have did. This is the system of a linear equation is given. Over there, I have written in the format of x plus y plus z. Over here, it's written as a matrix. Okay. Now, how we have to find out whether it has a unique solution, infinite many solution, no solution, exactly 2 solutions. I'm giving you the hint. First, find out the rank of the matrix. Okay. If the rank of the augmented matrix is equal to rank of the coefficient matrix is equal to the number of a variable, then it has a unique solution. One. Then the next one is if the augmented matrix rank is not equal to the coefficient matrix. Okay. And third case is if the both are equal, okay, but it has a less than, its value is less than the number of a variable, then it is an infinite case. Okay. Using that method only can lead you the final answer. These all are from the previous year question, multiple examinations. Okay. Anyone got the answer for that? Anyone? Unique solution. Okay. Let's see. This is the basic theory that I have written. No need to worry about. The same theory I have written again. Okay. So basically, we are trying on this over here. Okay. Here the matrix A is given, matrix X is given, B is given. Okay. So we can write as an augmented matrix. I have written as an augmented matrix. Now the next task is to find out the our rank. Okay. Doing the basic row operations. Okay. I can see that row operations is anything. Okay. It's nothing to worry about that I'm applying this method only. You can apply for any row operations. Our motive is just to make the lower upper triangular matrix, the lower element is equal to 0. Okay. Now, if I'm finding the augmented matrix, the rank of the matrix is equal to 2. The rank of the augmented matrix is equal to 2. The rank of A is equal to rank of the augmented matrix, that is 2, which is less than the number of a variable. In that case, system is consistent and has an infinite many solution. One student has got the unique solution. Please recheck. I think that the value is coming as an infinite many solution. Okay, because the number of a variable is equal to 3, the number of the rank is coming as a 2. 2 is less than 3. In that case, it will be the consistent and infinite many solution. Got it? Fast. Okay, because in the examination you will also get only 2 to 3 minutes. If you think that you can solve this question using the 5 minutes, you are actually killing your time. So don't use the 5 minutes trick. Just 3 minutes is enough. See this question. Two matrices A and B are given below. A is equal to PQ RS and B is equal to P square Q square PR plus QS, PR plus QS and R square plus S square. The rank of the matrix is N, then the rank of a matrix is equal to B is equal to what? Now, the first thing is they are squared and they are added to. Okay, they are multiplied and they are added to. They are multiplied, they are added to. They are squared and added to. So suppose if in that case, if the value of A is equal to the rank of the matrix A is equal to given as N, we have to find out what is the rank of the matrix B. Okay, anyone has any idea how to solve this? Anyone? Okay, now basically we are talking about only the rank of the matrix. This theory I have given you for you guys. Okay, the determinant of the matrix A can easily find out because it's a 2 cross 2 matrix. We can find out the determinant of that. Okay, same determinant of the B can also be found out. Okay, now if we are just looking at the thing, okay, in that case P square plus Q square R square plus S square minus PR plus QS whole square. Okay, Now doing the this part, okay, that is the p square r square plus p square s square plus q square r square plus q square s square minus p square r square minus q square s square minus 2prqs. Okay, p square r squares to p square r square cancel, q square s square to q square s square is cancel, ps p square s square plus q square r square minus 2p qrs. This is nothing but ps minus qr whole square. Okay, ps minus qr whole square. Now the value of this is given. Okay, ps minus qr. Once we are doing the square, we can find out easily that the rank of that matrix. Okay, so that a square value, after that there is a solution given. Okay, the approach, I am just giving you the approach. Remaining that part is not difficult. I have this question is just done. Okay, is there any issue in this question? Is there any issue in this question? Nothing? Is it unique? Is it done? Is it done? Okay. Okay, and then row sign, you understand now? That is the rank. Okay, the rank of A, rank of B. So sometimes they also give you the row sign. So don't get confused in the examination. Once they're giving you the row, it means that they're talking about that thing. For the matrix of the same dimension m, n, and the scalar c, one of the properties does not always hold. Okay. See, I'm giving you the direct idea how to solve these questions. Whenever it's such kind of a question is given now, okay, do one thing. Apply, use one thing. Okay, suppose imagine M is 2 cross 3 matrix and N is 2 cross 2 matrix. Okay, imagine something like, take very easy example. Okay, 2 cross 3 or any other like 2 cross 3, 2 cross 2. Okay, or and you can also take that 4 cos 2, anything. Okay, anything you can take. So it's not it's not like you always take 2 cross 2 or 3 cross 3. You can use any kind of these things. Now the thing is, transpose of transpose is the transpose. This is the property. Okay, so this is the absolutely true method. Okay, this is also the property. Okay, this is also the property, right? But once you're looking at that mn is equal to nm, in general, in the normal multiplication, this property hold. 2 cross 3 is equal to 3 cross 2 is equal to 6. In the algebraic property, a cross b is equal to b cross a is equal to ab or is equal to ba. But once we are talking about the matrix, in the matrix format, this property is not always hold. Okay, in that case, if we are doing the reverse, it's not possible. Suppose if m cross n is possible, it doesn't mean that n cross m is also possible. It means that only this statement is incorrect. Remaining all three are correct. Okay, simply just apply the simple methods. Not, you don't have to focus anything else. If in the case, and on the basis of that, there are two more question has asked. First, this one is the most latest question. Okay, and previously they given you the values. Okay, in that case, the value they have given, and you have to find out which property has true. Over there, it given as a skew symmetry. One of the option was given like this: A transpose, something like this, A into A inverse, something like this. So something like this has given A into A inverse, value is equal to 1. Okay, something like this they have given, and find out the final answer. So don't give the rough idea like how they are exactly want us to give the examination, how they are exactly giving us the question. Try to find out how to solve these problems. Okay, these are the normal method to find out to solve the problem, I believe. Sir, in question 5, how can we know to find the determinant? Okay, just give me the question number 5 idea. In question number 5, yeah, the question was, how can we know to find the determinant? Okay, Doing the determinant value is just like this value minus this value. So PS, I believe determinant is not difficult, minus QR. If this data multiply by this data, so P square plus Q square R square plus S square minus PR plus QS, PR plus QS. Simple. Through this you can find out the determinant. Finding out the determinant is the only this thing, like I have just done the cross multiplication, that's it. Clear? Is it clear? A bit accelerating mode, okay, because we cannot complete the whole question. Okay, this question is like this. Now I told you that one question has also asked on the same theory. 1 tan x minus tan x and 1. Okay, for the A, the matrix is given as a 1 tan x minus tan x and 1. The determinant of the A transpose into A minus, what will be the value? The first thing is you will find out the determinant of this method. Okay, find out the A transpose, then A inverse, and do the multiplication, find the final answer. Second, okay, you can also find out these value if you understand the basic properties. Okay, first I'm going to show you the normal property for any rank. In any rank we don't usually find determinant. Yes, Saurav, generally we don't find the determinant, but in the question they have asked that the determinant value of a PQRS has given. In that case, if the determinant value of a PQRS is given, it means that the next question, that is the P square plus R square, PRQ plus QS, PR plus QS, and P square plus R square. In that case, since the question is in the format of a relation, okay, that relation is from PQRS matrix. Okay, if the determinant of the PQRS is given, in that case you have to go for that one too. Any other method will be not calling off in that case, because there is the only single method to solve this question. Yet you can go for the augmented matrix, but that will make you the 4 cross 4 matrix. In that case, the calculation will be too much, right? Now, so this is the question. Okay, I believe everyone has seen the question. The first thing is, like, first I'm going to find out the transpose. Okay, so the simply using this formula is also a method. Okay, for the 2 cross 2 matrix, A inverse is equal to 1 upon AD minus BC, D minus B minus CA. I'm again telling, I'm not recommending this method. I'm just telling you because this is the one way to find out the answer. Okay, now for the matrix 1 tan x minus tan x and 1, A transpose and A inverse is given. Okay, in that case we have found out the A transpose, in that case we have found out the A inverse. Once we have found out these things, now A transpose into E inverse, you just do the all calculation value, all the trigonometrical ratio value. Once you have done so far, you will get the final answer is equal to 1. Okay, so after doing all the calculation, I believe this will take at least 5 minutes of your time, and the final value is coming as a 1. This is the one way to find out the answer. Okay, the next way to find out the answer is what? This one, A transpose into A inverse. Okay, so A transpose into A inverse, in the modulus form we can separate them. Okay, since A transpose, A inverse is equal to what? 1 upon mod A. Okay, and A transpose, if you're taking the mod, that will be again the same thing. If you're doing so, the value will be coming as a 1. So whenever any question is appearing at A transpose into A inverse for 2 cross 2, 3 cross 3, 4 cross 4 matrix, that is a square matrix, in that case the final value will be 1. Just close eye and just mark on the 1 on that case. That's it. Okay, no need to solve like this, just mark as a 1. That's it. Is it fine? Okay, next, again the rank of the matrix we have to find out. Simple question. Okay, just for the rank, just we have to find out the matrix and the augmented matrix. Basically the row operation we have to do. Basic row operations I have done. I'm not solving this because we are solving this question like 3 times in a row. Number of a non-zero rows we have to find out, and in that case the number of a non-zero row is coming as the 2, so the rank of the matrix is equal to 2. This is GATE 2018 question. If you can see, go check, this question is available over there. Okay, so simply rank of the matrix they have found out. Even in 2023 question paper computer science examination, simple rank of the matrix they have found out, simply rank of the matrix. Okay, the trigonometrical values has given, and first is that sin square theta plus cos square theta value like this has given. First you put the values of that trigonometrical function, or somewhere it's given as a sine 45 degree, that the value of that is equal to 1 by root 2. They have given this, and then you have to find out the simple like this. Okay, next, this one is a really important question asked in 2015. Most of the people have no idea what is Euclidean norm. Okay, so Euclidean norm, and the vector is given as this. So most of the people has understood this is the vector algebra question. Okay, but this is not the vector algebra. I'm going to tell you what is exactly Euclidean norm. Okay, so Euclidean norm is nothing but it is the value of the, first you do the transpose. Okay, whatever the value is coming as a transpose, basically the root of square of every value and their addition. Square root of 4 square plus minus 2 square plus minus 6 square, the square root of that is the Euclidean method. Okay, so to find the Euclidean method, all you have to do, just do the transpose, do the all the square, make them under root, add on the value, find the final under root square value. Okay, that will be the final answer. In that case, root 56 is the final answer. This is 2015 question. Okay, really important question. Most of the people have no idea what is exactly Euclidean. This is the answer for that. Really easy question. Okay, next. Now this, a matrix A is equal to 3 by 2, 0, 1 by 2, 0, minus 1, 0, 1 by 2, 0, 3 by 2 has a distinct eigenvalue, and one of its eigenvector is given as this. Which of the following is the another eigenvector of that? I believe if the eigenvalue and eigenvector concept of yours is clear, that is a very visible thing. We have a 3 distinct eigenvalues. Okay, one of the eigenvector is given. We have to find out the another eigenvectors if the matrix is also given. Let's see. If the matrix is symmetric, this is the really important thing. Okay, the matrix is symmetric and the product of the transpose of a one eigenvectors to the another eigenvector should be 0. That's it. The question is solved over here. If the matrix is symmetric, the eigenvalues multiplication should be equal to 0. Now let's check whether the matrix is symmetric or not. Okay, so if you see that part, the diagonal value is 3 by 2, minus 1 and 3 by 2. Okay, the transpose, if you are taking about the, so transpose of A is equal to the both is equal to the transposable. Okay, so if you are taking the transpose, the value is coming as the same. In that case, what will happen, the matrix, once we are doing the transpose, the matrix of A is equal to A transpose. In that case, 1, 0, minus 1 can be the another eigenvector, because the multiplication should be equal to the other eigenvectors should be equal to 0. In that case, only one factor is falling. In that case, that is this. I'm not giving you the difficult ideas to understand or think about these questions. What I'm trying to say, solving a question by looking at the question is how, once you are in the examination, most of the student has asked in the live sessions that how to approach the problem. I'm also make the time limit that in this much amount of time I have to solve this much amount of a question. Okay, so definitely I will take a little bit less time than yours, but the thing is the method of approach. Okay, if the question is given, the how you are first going to approach the question, this is the important thing. Okay, next, M is 2 cross 2 matrix with the eigenvalues 4 and 9. The eigenvalues of M square is equal to what? A lot of people have just done the assumptions on this question, and this question was accurate by them. Okay, that the value of M is given as a 4 and 9, then M square is equal to 16 and 81. So something the assumptions they has done. Okay, see, M is the 2 cross 2 matrix with the eigenvalues of a 4 and 9, right? So the eigenvalue is given, the eigenvalues is given. Okay, the theory is that the same thing. Okay, that we have done. If the eigenvalue is given, it means that For the returning eigenvalue, the value will be considered as a lambda square. Okay, that's why I'm saying so. The value will be m square. Okay, so for the 4 and 9, that will be 16 and 81. That's why I have shown you that if the people who have just done, this is the thing. If the lambda is the eigenvalue of the matrix A, then lambda is the eigenvalues of the matrix AN. Okay. So if 4 and 9 is given for the lambda for 1, okay, for 2, that is the m to the power n, when n is equal to 2, in that case lambda is equal lambda to the power n, lambda to the power 2, that will be equal to 4 square 16 and 9 square 81. That's it. Directly questions, I am telling about the question that will directly ask in the examination. These are the important theories. They are not going to ask you to find the inverse of the data, find the determinant of the data. They are going to ask the question based on these problems. So focus on these are really important. These generally are not written in the books too. Okay, once we are solving the PYQ, then we will get to know the important concept which are actually important and which are not. This question is easy. Okay, I have seen the question, that's why I have written in the our PPT. The determinant of the value is given as this. Okay, any value determinant is given. That suppose if this we are talking about, so determinant for that, first find out the minor, then cofactors. Okay, then find the our determinant value. We can use this method for 2 cross 2, 3 cross 3, 4 cross 4, 5 cross 5, any kind of a matrix. This value is just a little bit difficult. Okay, little bit difficult as in that it will be a little bit lengthy question. That's why this question is important. Otherwise, it has a 3 row and 4 column. Okay, so 3 cross 4 matrix, that's why it's a little bit difficult in the bit of the calculation. That's it. Theory wise, you understand how to solve this question. Okay, so we have just found out the minors for everyone. Okay, because first we have found out this. Okay, minus 1 to the power 0 into minus 1. Okay, see, this one is the first place. Okay, so for the first place, this will be positive, negative, 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 positive, negative. So first thing we have found out. The remaining the minors we have found out. So cofactor you have to find out. And then once you have removed that part, okay, so this matrix is remaining. Once we are moving that plus 1, okay, so plus 1, then this matrix is remaining for 2, this matrix is remaining. Any of, you can go for the row wise or the column wise, you can use any of the method. It's not applicable for only use this method. You can use any of the method. Just go. I am telling you, just a little bit lengthy this is. That's it. Okay. The final answer for this question is 88. You can also solve. Okay. If you want to solve this question, just do one thing. Little bit practice you do on your own too, because the most important thing, this is the most important time. I'm here. I will come in front of you. I will bring some questions and make you understand how to solve this question. Okay, but until unless you are not doing the practice on your own, you will not able to understand. Because once we are solving, we will understand what exactly the time as well as the calculation mistakes we are doing on your own, rather than the person who is teaching us. Okay, so I'm just here to tell you the type of a question that has asked and the question approach, but only you are the only person to whom you are going to solve this question. So just make sure you are able to understand this question or not. Okay, next. Now see, the cofactor Cij of the element Aij in the determinant lambda, okay, in the determinant is defined as minus 1 to the power I plus j mij, where mij is called what? Minors. Mij is called as a minor of the element. This one is the cofactor and this one is the minor. So basically it's the multiplication of the cofactor and minor. Then we solve the part. Okay, major, multiple, matrix, these are all incorrect options. Minor is the only correct option. Okay. Okay, question was asked 3 to 4, just what it's written. Wait a minute. Wait a minute. This you have understood? This you have understood? I'm not saying this one is a square matrix. Okay. Whenever I have told you that this one is a square matrix, tell me. I have expanded the matrix once you have taken 0. Okay. It means that all this element and all this element you have to cancel. Okay. 0, 3, 0, 3, 0, 1, 0, 1, 2. This we have to write. Okay. The normal method to find out the expansion of a 3 cross above 3 cross 3 matrix. Okay. Next, I can go with 0, 1. Okay. See this. I can go with any one. I can go with 0, 1, 2, 3 or 0, 1, 2, 3. Any of the method. Okay. Now the next one is 1. So since this one is a plus, then this one is a minus. Okay. So for plus minus, if I'm going to remove this part, so 130, 130, 130, 201, 312, 201, 312, like this. I'm not saying in question the matrix was different. Yes, this is the expansion. Okay, I believe now you have understood. I'm going to make you understand the first part. Okay, suppose if I'm doing the expansion like this, see, if I'm focusing on 0, so all the element across the 0 will be cancelled. 0 minus 1 to the power plus 1 plus 1. Okay, the matrix will be, see, this part, this part, this part. Okay, 0, 3, 0, 3, 0, 1, 0, 1, 2. Okay, next. Next, I'm assuming this one. Okay, so now for that one, I have to remove that part and that part. Okay, so 1, 2, 3, 1, 2, 3, 301, 301, 1, 0, 1, 2, 0, 1, 2. Okay, next, I'm again removing that part. Now next we have to go, I'm eliminating for the 2. Okay, I'm focusing on the 2. For the 2, I'm removing all this one and this one. 100, see this, 100, 100. Okay, then 231, 231, and then 302, something like this. Which slide? Okay, 1030. Okay, you are telling me the questions are different. Okay, you are asking for the question. Okay, I got it. Okay, wait a minute. Actually, these slides are overlapped. This one, actually, this was the 2 questions. This one is overlapped. Sorry. This was from my mistake. Okay, the question was overlapped. Actually, there are 2 questions in that. This was the first question, and there is another question. I have just solved the another one. My mistake. This question has overlapped. Sorry. I have solved this one. Okay, but in the previously you can use the same method to find out the another question. Okay, that the previous question, that the original question was this. Okay, and due to the slide overlap, the question was replaced. Okay, that's why this has happened. Sorry, this is the mistake from my end. Now you can solve this question like the same way. Okay, I hope yeah, that was the good, actually the good point. Actually, those people who have raised the issue, that was good, because I was also in the hurry to form the slides. Maybe it has skipped from my mind to solve that part too. Now, next question. If the lines ax plus by plus c is equal to 0, bx plus cy plus a is equal to 0, cx plus ay plus b is equal to is the concurrent. Okay, in that case, what will happen? What is the concurrent line? Same line. Okay, so we are talking about the same line. Now, if the same line is given, the determinant is equal to what? 0. Just solve the determinant. Okay, ABC, BACA, CAB. If you're solving, AQ plus BQ plus CQ is equal to 3ABC. AQ plus BQ plus CQ is equal to 3ABC. Final answer. Okay. Original question 12 is not the square matrix, so whether determinant is equal to 0. Okay. First understand this question, okay, because once you're showing me the previous slide now, then again it's for me it's also difficult. Solve first this question. If you got this question, then we can move to the previous slide. Okay, you got this question now? Is it fine now? This question is done, right? Then we will move to the question number 12. We will discuss that part again. This question is done. Okay, I'm assuming this question is done. Moving to the question number 12 again. I think there are some issues over there. The determinant of the matrix, we just solve that part. Okay, we are going to solve. If this question is gone, I believe there is a remove this question. Okay, let me do one thing. Okay, just leave that part. There is a missing part. There is a row missing in that case. Okay, just solve this part. I believe this one is fine. The question part, just leave that part. There is a row missing over there. Just solve this question. Now is it fine? I believe that question was different question and this question was different. It's a slide mismatch. That's why it's happened. Just solve this question. Leave the previous question. Is it fine now? There is a one complete row is missing over there. That's why the calculation error will come. Okay, great. Now next, I believe 14 is done. Now, this one is the really important question. I believe this one is the last question of our session. And this question has asked for the 2 marks. Okay, that's why this is the really important part. The pth, qth and rth terms of the HP is ABC respectively, then BCCA AB, PQR 111 equal to, first of all, AP is equal to what? Suppose A plus n minus 1 into D. Okay, the terms are A plus D, A plus 2D. HP is just opposite to this. Okay, 1 upon A, 1 upon B, 1 upon C. Okay, this is their terms. Okay, so 1 upon B minus 1 upon A, 1 upon C minus 1 upon B, something like this. We can say HP is just inverse of AP or AP just inverse of HP. Okay. Now the terms pth, qth and rth term is given as a ABC and we have a determinant given. Then this value is equal to what? We have to find out. See, we will start with the bit by bit. Okay. This theory I will just make you understand that the AP and HP relationship. Now, if you are just expanding that matrix part BCCAAB PQR111, I'm just doing the basic expansion. Okay, nothing else, because before doing the basic expansion we cannot understand at which time we have to make the variable separable value and find out for which we are using which data. Okay, the first I have just done the expansion of the determinant. Next, now pth, qth and rth term is given as a ABC. So pth term, qth term and rth term is given as a ABC, that the equation we have found out. Okay, for same thing. Okay, 1 upon A is equal to x plus p minus 1 into D for pth term, 1 by B is equal to x plus q minus 1 into D for qth term, and for rth term 1 by C is equal to x plus r minus 1 into D. This is the rth term. Okay, so pth, qth and rth term as given. Same, we have just find out the common difference. Okay, so common difference through which we can find out the common difference. So common difference we have found out. Now we have found out the first term, we have found out the common difference, then we can again find out the value of the data. Okay, what exactly? See, since the common difference we have found out, in that case the common difference, we know that x is equal to A by B is equal to C by D is equal, I think this data. Okay, this data is coming from our series part. If you are not able to understand this part, go and revise your series part. This is a really important thing. If x is equal to a by b is equal to c by d is equal to e by f, what I am trying to say here is vector algebra or the matrix part or the determinant part is not solely the question where the question is solely asked on these topics. See this question. This is the combination of the whole matrix, whole determinant, AP, GP, HP series, and the arithmetic, okay, plus the algebraic sections. So these things are you need to remember, okay. Once you have understood now, A plus C upon B plus D plus F. Now this part is easy, okay. D is equal to B minus A upon this. So D just add on, okay. This whole part just add on. The upper denominator part will be coming as a 0 because B minus A, C minus B, A minus C. It will be coming as a 0. In that case, the option of that value will be equal to what? 0, because the numerator part is coming as a 0. What happened if the denominator will come as a 0? Then the whole value will be tending to infinite. This is the whole type of a question we have done, okay. Actually, my motive is not here to solve the questions and to make you understand that you are not able to solve the question and see I am solving and you are just looking at me, okay. This is not the motive. My motive is here that we are in the 2nd of January, okay. Only 20 days has left, 20 to 25 days has left on which we have to continue this whole part, okay. Now this today we have covered that part. In the tomorrow session we will discuss the vector algebra and another sessions too, okay. So whatever the topics that we are covering, whatever the topics that we are just moving, in that case the theories and numerical as well as the conceptual part that we are learning, just learn that part at least. I'm going to give you the one thing very important. 8 sessions will be conducted in the January. Mine solely mine will be 8 sessions will be there, and I'm 100% sure that at least 5 to 10 questions. I'm asking about not 5 questions or 10 questions, 5 to 10 questions, not marks wise. I'm talking about at least will become just only this 1 or 2 hour session, because we are covering the PYQs. PYQ is something like we are covering almost every topic, okay. In the normal theoretical way, we are covering only the basic topic or the simple questions, but in the PYQ, we are covering almost everything, okay. And this is really important part. Just be with me, okay, and just be with this 390 challenge, okay. And if you think that if anything you are not able to understand, you can also pose the question, okay. You can also ask to me that this question is not able to understand. But if you think like, okay, this question as well as on looking at this question, you think like this data is important, just do the practice, okay. I'm not asking anything for you guys, okay. Just do the practice. Look at the question, look at the solution. I haven't provided you the detailed solution, okay. So you can stop the slide, you can see the slide. So everything is over here, okay. Next sessions will be on 4th of January, okay. So my session will be on the Tuesday and Thursday. So once the Thursday session will be end, again the next Tuesday will be my session, okay. And the day after tomorrow session we will discuss about the vector algebra, right. This is all for today, guys. Thank you so much for watching. Thank you, and do practice, okay. Thank you.